this. They give you a third line. Of course they do. Line L3 is given by this vector equation of a line, and it passes through point C. I'm sure glad I just found point C because we're going to have to use it, of course. And now they want to figure out the value of P when this equation is equal to C. So this x, y, z right here that we see, this is now going to be my -2, 2, and 5. That's going to be point C. So I'm going to say -2, 2, and 5. It's going to equal 3, -8, 0. That's some point on the line 3. So -8. And then we got plus P, 1, -2, -1. Okay, so -2, let's actually just look at the bottom equation. Let's not do anything else. I was going to say the bottom part. 5, we're going to say 5 equals what? Equals 0 plus P times -1. So basically it equals -P. That means P is equal to -5. They simply wanted me to find the value of P, and that's it. It's -5. You're done. Nothing else to look at for that. Okay. This is question 4. I am going to skip question 4 because we did this in class on the 2D, 3D mixed review that we had. So this has been completed already. You shouldn't need me to do this. I'm going to go on to the following question, number 5. Okay, so we have this. Points P and Q have position vectors, and they want me to find PQ. So this is going to equal Q minus P. Q minus P. So we're going to take Q, subtract P, and figure this out. So this is -4, 9, and -5. -4, 9, -5. We're going to subtract -5, 11, and -8. -4 minus -5 is -4 plus 5, which is in fact 1. 9 minus 11 is in fact -2. And -5 plus 8 is in fact 3. So the position, the vector PQ, is actually given by 1, -2, 3. Those are its components there. Now the following question is hints. Hints is a buzzword that means use the answer you just found. Hints show that L1 can be written as this. Alright, so L1 has a vector equation of a line. Very well. And they're using R instead. So we have R. And this is going to equal some point vector plus a scalar. They're going to use S by the looks of things. The scalar S times a direction vector. Okay. Now, a point on L1, since they told me up here that L1 contains the points P and Q, alright, then one of the points I'm going to use for L1 is this one, which is P, -5, 11, and -8. Okay, it's a -8. I don't know why it keeps doing that here. So, and then I have this directional vector, which is actually the same thing as PQ, the thing I just found. So I say 1, -2, and 3. And now I'll write some vector components of this. So the I component, -5 plus S times 1, which is now -5 plus S. That'll be your I component. And then I'm going to add a J component, which is now what? 11 plus -2 times S. So 11 minus 2S. And then my K component, which is -8 plus 3 times S. So -8 plus 3S. And that will be my K component. If you notice this here, this looks very similar to that because it's the exact same thing. I have shown this is in fact what it is. Okay, so that's that answer. They've given me another point that lies on L1. So this is the equation for L1, and they're giving me a point on it. So I'm going to use this point and substitute it for R right there. So I'm going to have 2y1, z1. And this is going to equal -5, 11, -8. Plus, I do not want to use S. I'm going to use a different letter because S looks like a 5 to me. I'm going to use W. I'm going to say 1, -2, 3. Okay. Of course, they want me to find what? Y1 and Z1. I don't know what these are. So let's take a look at the top equation. This is a 2, and that's going to equal what? Negative 5 plus w times 1. So it's going to equal negative 5 plus w. Now I can solve this equation for w. Add 5 to both sides. W is equal to 7. So let's pretend for a second this w is in fact a 7. Now I can find y1, because y1 is going to equal 11 plus 7 times negative 2. That's 11 minus 14. 11 minus 14 is negative 3. And z1 is going to equal negative 8 plus 7 times 3. So that's negative 8 plus 21. Negative 8 plus 21 is 13. So your two answers for y1 and z1 are negative 3 and 13. That's that answer. Keep pressing forward. Alrighty. The line L2 has the equation given by this. So we got a point vector, a scalar, and then a directional vector that is being multiplied by. Okay? It tells me the lines L1 and L2 intersect at point T. Here's the equation right here. This whole thing right here is L1. They give me the equation here for L2, and I want to figure out where they're crossing each other, so I have to set this equation equal to this equation. So let's ignore the 7, so it's not 7 anymore. And I set this equation equal to this one. So negative 5 plus w times 1, which is negative 5 plus w. I don't know why it's doing that. Negative 5 plus w is going to equal 2 plus 1 times t, or 2 plus t. That's one equation. And then I'll get another one. 11 plus negative 2 times w, or 11 minus 2w. And that's going to equal 9 plus 2 times t, so 9 plus 2t. And then I'll solve these system of equations here. I'll solve this top equation for w by adding 5 to both sides. So then I'll see that w is in fact equal to t plus 7. I will take this t plus 7 and substitute it into w right here for the second equation. So what I'll get from that is 11 minus 2 times t plus 7 is equal to 9 plus 2t. That means 11 minus 2t minus 14 is equal to 9 plus 2t. And then we'll solve this equation here. I'm going to add 2t to both sides, so that'll give me 4t. And then I'm going to subtract, 11 minus 14 is negative 3, and then I'll subtract 9. So negative 3 minus 9 is negative 12. So 4t is equal to negative 12, and then divide both sides by 4. T is going to equal negative 3. This isn't the answer, but I know what the scalar is. The scalar right here is negative 3. So now I can actually figure out this equation for t, this position vector t, where they actually are intersecting. So I can do it this way. I can say then this is 2, this first component. Let's find t. Let's put it up here. This first component is 2 plus negative 3 times 1. So 2 plus negative 3, which is negative 1. The second one is 9 plus negative 3 times 2, so 9 minus 6, which is 3. And then the third one is 13 plus negative 3 times 3, so it's 13 minus 9, and 13 minus 9 will be 4. So the position vector for t is this right here. This is your answer for part C. Calculate the angle between the lines L1 and L2. So now we have to do a dot product. Here is the vector equation, the directional vector for L1 and the directional vector for L2. So I'm going to take the dot product of this and this. So I'm going to go ahead and write them down here and say 1, negative 2, 3, and the other one is going to be 1, 2, and 3. I notice these numbers look very similar, which means their magnitudes here are actually going to be identical, which is kind of handy actually. Let's do the dot product first. So we're going to multiply the x's. 1 times 1 is 1, negative 2 times negative 2 is negative 4, and 3 times 3 is 9. So this is going to equal -3 plus 9, which is 6. Okay, that dot product is positive, which means the angle between them is going to be an acute angle. Recall this formula for the dot product right here, and this is times the cosine of the angle between them. If I find the magnitude of this, this is going to be basically negative. It's going to be 3 squared plus -2 squared plus 1 squared. So it's going to be 9 plus 4 plus 1, which is actually 14. Okay, this is the same thing here. It's going to be 3 squared plus 2 squared plus 1 squared, which is 9 plus 4 plus 1. So both of these are going to be basically root 14 for magnitudes. Root 14 here and root 14 here. So to get the angle theta, it's going to actually end up equaling the cosine inverse of 6, the dot product, divided by root 14 times root 14, which is actually just 14. So now we'll consult the trusty dusty calculator and then get going on this. This is control divide. This will be 6 divided by 14. And this will equal 64.6 degrees or thereabouts. So that would be your answer. That's the angle between the two vectors. All right, next question. I believe this is the last question, finally, because we've been at this for a while. So let's take a look at this. We have a parallelogram. Fancy. Okay, it has 6 faces. The coordinates of A and B are given respectively. Here they are, this and this. So let's figure out what the questions are. They want me to find the vector AB. So that's easy. It's going to be B minus A. They give me B, they give me A, let's subtract them. So this is going to be 17, 2, and 5 minus the vector A, 7, -3, -5. So 17 minus 7, most people call that 10. 2 minus -3 will be 5, and 5 minus -5 will be 10. So the vector AB is 10, 5, and 10. The next follow-up question, of course, is what is the magnitude of AB, the length of the vector AB? Let me go ahead and draw vector AB on this diagram here, because this is actually kind of important to see what's happening. I have a point, and I have a vector going from A over to B. Now they're asking me for the magnitude of this vector, which is basically its length. And I can find its length using the distance formula. So I'll take these components I just found, and I'll take 10, square it, add it to 5 squared, add it to 10 squared. I know that 10 squared is 100, so I have 100 plus 100, which is 200, and then 5 squared is 25. So it's 225, root 225, and that actually is the same thing as 15. Root 225 is 15. So what I'm declaring then is that the actual length of AB here is in fact 15. That's the distance here, which means I now know this distance, and all these edges that are corresponding to it. So the following information is also given. They give you the vector components for AD, AD's magnitude, the components for AE, and AE's magnitude. It's worth noting that AD is 9 and AE is 6. Okay. From A to D, this magnitude, they tell me, is 9. And from AE, which is going from here to here, this magnitude is 6. What they've given me is the length, the width, and the height of this rectangular prism. Now, what I suspect they're going to want me to do is find a volume, because if you multiply those together, that's what you get. And I'm going to wait for that question. I'm pretty sure it's coming up. But the next question, before they get there, is, of course, calculate the dot product of AD and AE. Well, the dot product of AD is this, and AE is this. It's pretty obvious to me that these two vectors are, in fact, perpendicular to each other, or orthogonal. The dot product should equal 0, but let's solve it anyway just to humor them. Alright, so they want AD and AE, and they tell me, of course, what? AD is -6, 6, and 3, and AE is -2, -4, and 4. Alright, so we're going to use these for this question. -6, 6, and 3. Alright, I'm going to write that because I don't have it right here. -6, 6, and 3. And AE, what does that equal to again? I can't remember. This is going to be, let's jump down, -2, -4, and 4. -2, -4, and 4. So let's do the dot product. So the dot product of AD and AE, I'm fairly certain this will equal 0. -6 times -2 is 12. 6 times -4 is -24. And 3 times 4 is 12 again. Well, that's going to be 24 minus 24. And that's, of course, going to equal what? Big surprise. It's going to equal 0. So that's the calculation. I already knew that, though, because quite obviously from the drawing, AD and AE are, in fact, what? They're perpendicular. This is a right angle right here between them. As it turns out, they're going to ask you for a whole bunch of other sides that correspond in this fashion, AB and AD. Okay, AB and AD. I don't know. Let's take a look at that. AB is right here, and what is AD? This right here. I'm going to guess that this angle between them here is also a right angle. And without actually solving it, I'm just going to say that dot product is equal to 0. Now they want AB and AE. So this one and this one here, I'm going to say this is also a right angle here from AB to AE up here. So I'm going to say all these dot products are actually equal to 0 without actually solving all of them, because that's kind of a waste of time, really. Hence, write down the size of the angle between any two intersecting edges. Well, if the dot product is always 0, regardless of what the edges are, that means the angle between them is, you guessed it, 90 degrees. Those are a bunch of right angles. Now, here's that question I was waiting for. Calculate the volume of the solid. The volume is, of course, given by the length times the width times the height. L times W times H. And I have all those things because they gave them to me. 15, 9, and 6. So 15 times 9 times 6. Alrighty, so let's zip back to that question and figure this out. The volume is 15 times 9 times 6. And then the calculator tells me that 15 times 9 times 6 is 810. Very well. Now, I'm going to say that's in square units. Since they don't tell me the units, I'm going to say, I'm sorry, cubic units. And that's what I'm going to say, units cubed, whatever they are. The coordinates of G are 9, 14, and 12. Find the coordinates of H. Alright, so let's write that on our little diagram, 9, 14, and 12 for G. Alright, so G right here is 9, 14, and 12. And what they ask me for is what is the coordinates for H right here. I have a vector going from H to G that is actually parallel and equal in magnitude to the vector AB. So that's what I'm going to use to get this answer. You see, I have found AB already. AB right here is what? 10, 5, and 10. So what I'm going to do then is say then, okay, because AB is 10, 5, and 10, HG is also 10, 5, and 10. They're parallel and equal in magnitude. The only thing is, though, is that HG is what? It's G minus H. And what that is to me, since I now know G, they gave it to me, is 9, 14, and 12. And I have to subtract the components of H. I have no idea what H is, okay? So I could say these components for H are, in fact, H1, H2, H3. X, Y, and Z. So H1, H2, H3. But I know that if I subtract these, it's going to equal Hg, which is 10, 5, and 10. It's the same magnitude as AB. And then I have three equations I can solve. So 9 minus H1 is 10. That means to me that H1 is negative 1. 9 minus negative 1 is 10. I now know that H2, 14 minus H2 is 5. So what do you subtract from 14 to get 5? H2 more than likely will be 9. And H3 is 12 minus h3 equals 10. That means h3 is probably 2. So these components, -1, 9, and 2, match my h's here. So I'm going to say the vector h is given by, the point h is given by -1, 9, and 2. So to answer the question finally, find the coordinates of h. H is given by -1, 9, and 2. That's done. Part E. Lines AG and HB intersect at point P. So let's figure that out here. AG and HB. I need to figure out where that is. AG, this is from this point here all the way up here to this corner. So we have a diagonal. This is going to be a terrible line. Oh my gosh. This is hard to draw. Yeah, that one was better. That is really awful. All right. So that's AG and HB, which is going diagonal this way. And somewhere in the middle, they're going to cross. Right in the middle of that prism. And I have to figure out, I guess, where they cross. Is that what they're asking me? I'm not sure. Let's see. They give me the actual vector AG, and they want me to find the angle. Okay? Where they intersect at point P, they want me to find the angle at P. Okay, this is worth taking a look here at the diagram then. If I want to figure out the angle at P where they cross, okay, from here, this is where they cross at P. I got AG and HB right here. So this angle where they cross, I can assume, I guess, they're asking for this angle. I'm not really sure here. If I use just HB and AG, that's actually going to give me, I believe it's going to give me this angle here where they cross. So I guess that's what they're asking for. So let's go ahead and do that. This is a dot product. Alright, but the only thing is, what I'm missing for this is, in fact, what? I'm missing the vector HB. But I already know AG, so we have to figure out what HB is. So that's going to be B minus H. As it turns out, though, HB is B minus H, and I already know what B and H are. Okay, so let's take the vector B. I don't remember what it was. Vector B they gave you right here. It's 17, 2, and 5, right here on the bottom. Okay. A lot of jumping around here. Sorry. Oops. 17, 2, and 5. And I'm going to subtract H, which is -1, 9, and 2. This will give me 17 plus 1, which is 18. 2 minus 9, which is -7. -7. That's awful. And 5 minus 2, which is 3. Okie doke. So now that I have HB and AG, let's take their dot product and get this answer. Let me extend this page here, and let's go for it. So I need the dot product of this vector and this vector. So we'll say AG, dot product with HB. It's going to be 2, 7, 17. Dot product with 18, -7, and 3. So this is going to be 2 times 18 plus 7 and -7 plus 17 times 3. Alright, so 18 times 2, that would be 36, minus 49, and that'll be 21, and 30, so that'll be 51. 51 minus 49 is 2, and 2 plus 36 is 38. The dot product is equal to 38. This angle is acute. And let's figure this out. So, this is 38, the dot product. We have to find the magnitudes of these two vectors. So, this is going to equal the magnitude of AG times the magnitude of HB times the cosine of the angle between them. The magnitude of AG is the square root of 2 squared plus 7 squared plus 17 squared. No idea what that is. You have to use a calculator. Alright, so I'm going to say 2 squared plus 7 squared plus 17 squared. That's 342. Alrighty. Let's jump back over the question. So this is root 342. Now to find the magnitude of HB, which is 18 squared plus negative 7 squared plus 3 squared. So HB found in a similar fashion. Plus negative 7 squared plus 3 squared. We don't know what that is either, so let's try that. 18 squared plus 7 squared, or negative 7 squared, doesn't matter, and 3 squared is 382. Long problem, this one. Alright, finally we can get the angle. So theta is equal to the cosine inverse of 38 divided by this times this. So it's going to be root 342 times root 382. And this is going to be, oh, I can't wait for this. Cosine inverse, control divide, 38 divided by the square root of 342 times square root of 382. That angle will be 83.96 or 84 degrees is what we'll say. Close enough there. So that's about equal to 84 degrees. Very well. All done. That was the answer for that one. That should be the end of your review, and it is. Alright. I appreciate you watching, and I hope you got some something out of this. And then good luck on your test tomorrow. Appreciate it. Bye.